Hello and a very warm welcome to our Automation Era event. Today our event is hosted by the LSE Data Science Institute, and we are very proud to welcome Professor Leslie Willcocks and Angela-Sophia Gebert, who will give a conversation and discussion of how technology reshapes business and how it changes how people work today.
So I'm going to use this rather jazzy title, Robo Apocalypse Cancelled, because I wrote an article with that title in June 2020 and another one in June 2021, which addressed the issue that for too long people have been seeking headlines by talking about automation as a job killer and focusing entirely on the job displacement impacts of automation. I think most of the reports coming out these days have reached a more nuanced and complex understanding of what these automation technologies do, and hopefully you'll go away with a much better understanding as a result of the presentations today. Very quickly go into um, the research base I'm using. Obviously, you can see on your right-hand side, I've written a few books on this with my colleagues, and I've got a forthcoming one, Globalization, Automation and Work. And that's based on this database we have of surveys of automation and work and client adoption case studies. We have about over 850 client adoption case studies that we draw upon, successes and failures, different types of technologies, reaching into more recently digital transformation. So I'm going to first of all talk a little bit about what I'm calling automation technologies. So if we could go to the next slide, really there are, in terms of automation, three magic phrases. One is robotic process automation, or RPA. Another one is cognitive or intelligent automation, IA. And the third one is AI, artificial intelligence, which is normally enormously hyped, and very often the other automation technologies are subsumed under the umbrella term AI, which they are manifestly not. If you're going to define artificial intelligence as replicating what human minds can do, they manifestly don't do that. They replicate some of the things that humans can do, very often faster and more efficiently, but they are not artificial intelligence. My saying on that is that if it's artificial, it's not intelligent. If it's intelligent, it's not artificial. But going to the next slide, we'll see that the continuum of these technologies, which I call automation technologies, range from quite simple automation technologies. RPA is essentially using structured data, processing it through rules to produce a definitive decision or outcome, and automating this task and process in this way. And you can see that there are four kinds of robotic process automation. There's very simple desktop or RPA, which automates a typical task you do on the desktop. There's more sophisticated RPA linked with enterprise systems that can then operate across an organization. There are more simple, customized software development tools which enable you to create your own robotic process automation tool. And more recently, there's using RPA on a rental basis in the cloud, using RPA service organizations to provide yourself with a rented digital workforce, almost the automated RPA workforce. And then this is quite a small market, and indeed all this is quite a small market. The total by 2025 is likely, in terms of revenues globally, to be about $50 billion, which is very, very small in the history of IT expenditure, which goes into trillions. But increasingly, we're seeing being used, and Celonis is in this market as well, cognitive automation, or what it's become to known as intelligent automation. You know already that I don't like using that word intelligent when it comes to automation, but marketing reasons a lot of people do. This is where you're using machine learning, much more unstructured data collected from natural language programming, from vision sources, and driven through uh, rules-based algorithms to arrive at probabilistic outcomes, recommendations, and decisions based on what would seem to be the best course to take. And this is the area of massive expansion in the next 8 years, I would guess. Um, when they iron out many of the difficulties of implementing this stuff into modern organizations, there are a lot of challenges in doing that. But this will become more and more powerful. What makes it very powerful is that it's backed by uh, very good and improving memory, and also massively improving uh, powerful computing. So if we go to the next slide, there is a huge promise, as I've just outlined, to what I'm calling cognitive AI, automation moving into AI. They're the main ingredients of that. Uh, you're familiar with many of these phrases, and I'm not going to try to explain deep learning and supervised and unsupervised learning, but they are parts of how rules are developed, and improved rules, so that the machine improves its performance over time, and increasingly those machines are linked with natural language processing and machine vision processing in order to structure data or provide data in forms that the machine can handle with. And all these are backed by super fast processors. As I said, the promise is massive. But if you look at the next slide, so are the challenges. And this is why we've actually been very slow into uh, developing these technologies, surprisingly slow. The headlines far outrun the technology's adoption profiles. And there are a number of reasons for this. One of the biggest ones for organizations starting up into cognitive automation is data. You've got to get the data in some form that can be utilized. Unfortunately, there's a lot of difficult data. Most organizations have their data in unstructured forms, or not good forms, fuzzy images, uh, different languages, uh, in difficult documentation. A lot of data might not be available. It might be dark, it might be hidden, it might not be easily accessed. Frequently, you hear a complaint about we're not able to develop the technology because there's a dearth of training data. There's a lot of attempts to improve on that, but it's still a big problem for startups, especially in using cognitive technology. And then there's the question of dirty data. I mean, my phrase here is the dirty secret of big data is that virtually all business data is dirty. And if you're not using very clean data, then you can't necessarily trust the results of all the processing that you're doing with these kinds of technologies. A lot of you will also be aware that there are ethical issues with machine learning and using these technologies, but there are also quite a lot of other problems with machine learning. One of the ones that is very often not talked about is that actually a lot of this is reliant upon statistics, very traditional statistics, and uh, sampling and random sampling and things like that are very often the statistical base of what is being done is not very good. So it doesn't matter how much money you spend on technology, how clean you make the data, if the statistics is poor or unfocused, or doesn't cover the ground that you think it does, then you're going to get fairly poor results. But these are not the major problems. The major problems are in the bottom part of that diagram. The fact that these need to fit with social systems, political systems of organizations, that there's a lot of regulation around this area. The European Union in particular could be putting quite a lot of regulation and barriers around the potential of these technologies. Um, and organizations are themselves very siloed, and these technologies do not like siloed organizations. So the typical organization has silos in terms of strategy, structure, process, technology itself. Data is very siloed. Culture can be uh, very siloed in organizations, with different parts of the organizations having different cultures, managerial mindsets. So you've got to somehow, in order to achieve digital transformation, and utilize these kinds of technologies, break down these kinds of silos. It's very difficult to do, in fact, in practice, which explains to some degree the difficult deployment that a lot of these technologies and digital technologies experience. Moving on to the next slide, nevertheless, there is development which has been accelerated during the COVID-19 years, and the development is towards integrating these different automation technologies to develop automation platforms. And that comes from different directions. The robotic process automation vendors, the AI and analytics producers are trying to develop these platforms. Systems integrators are, and a lot of enterprise software producers, the big companies in that area, are moving towards integrated automation platforms. But the next stage, if we go to the next slide, is then integrating those automation platforms with all the other technologies that are available. I call them the smack Brader technologies. So automation of knowledge work, automation technologies are only one of 10 total technologies that are major for organizations in the future. And you see the list there. The bigger picture is all those, and I don't think I've even got augmented reality on there, which is the last day of my Smack Brader one, because it's been a recent development. So the big move is automating these automation, automating these technologies, automating work, integrating the automations, and then integrating those with these emerging digital technologies. So you can see why this is going to take years and years, but you can also see the enormous potential of these technologies here. We haven't even scratched really the potential of these technologies in our organizations, but we are going to over the next 10 to 15 years. So moving on to the next slide, that gives you an overview of the technologies I'm talking about. One of the interesting things about these technologies is that when people talk about them, they very often conflate the concept of automation with the concept of digital transformation. As I've tried to explain, the automation technologies themselves are a very small part of the technological development we're going to see. But very often when people talk about automation, the future of work, it's as if they're talking about all the technologies and not just the automation technologies. And this leads to an awful lot of confusion because people are not really clear about what they are talking about themselves, let alone the audience understanding what they're talking about. With that sort of caution in mind, let's move to the next slide. Um, where I want to give you a macro picture and then dive into what I think are the developments in the impact on work in the next 8 years. The simplistic picture, which was very one-sided coming out of 2013 to 2019, was that automation was going to be a big job killer. As you can see from these more recent reports, and certainly my own research from 2016 into organizations, that was never really clearly what was going to happen. It was clear right from the beginning when we looked into organizations that very often people were not using automation to reduce job numbers. They were responding to the fact that work was expanding enormously and there were skills shortages, and they had to uh, adopt automation as almost a coping mechanism in order to maintain productivity and revenue growth and respond, to the amount of work exploding. So the more recent reports here sort of support that picture. As you can see, they're actually saying that the net job loss globally over the next 10 years or so is going to be actually very small. I think I'll just home in on one figure there. The McKinsey Global Institute report reckons that the net loss as a result of automation will be about 1% globally in total full-time equivalents uh, up to 2030, so, which is not really reflecting what those initial fear headlines suggested. And all the other reports are corroborating that, as is my own research work. Um, but what is clearly going to happen if there's not going to be a net job loss that's going to be massive is there's going to be a radical shift in the type of work being done, which means big skill changes, and there's going to be variable impacts on different sectors, on different types of jobs and different types of workers. So let's address that as the truth that we have to deal with. So the next slide points out, and these are guesstimates, because remember, trying to predict about technology 5 years ahead these days is really a gambler's game. It's not. It's speculation once you get beyond 5 years. You've got some basis for predicting the next 5 years, but the variables are so great and unpredictable that really we're speculating beyond 5 years. So with that sort of note of caution, I still think that the trends that we know at the moment suggest this kind of picture, and I'm just giving it to you as a sort of working hypothesis, really, which is that there will be job creation, a factor that a lot of the earlier studies in the impact of automation didn't really factor in. They assumed that it's going to be small job creation as a result of automation. 90%, 9% of jobs in 2030 do not exist today. And the other factor is that despite many of the earlier predictions, it's not whole jobs that are going to be lost, it's parts of jobs, tasks and sub-processes within jobs. So the most typical pattern is that for 2/3 of jobs, some 30% might be more automated than before. But that's been a steady trend for decades, actually, when you look at the role of technology in work. There will be some shrinkage of some occupations. 14% of global workforce will change occupations. There will be jobs lost as a result of automation, but also jobs gained from automation. Some 8 to 10% of jobs will cease to exist, and that's been the picture ever since we've been using new technologies. It's not a new phenomenon with these emerging technologies. Remembering also that this picture of total automation has been widely overblown. We think only 9% of jobs today are actually wholly automatable. And the job loss, which everyone says is going to be in low skilled work, well, yeah, but it's not going to be eradicated. We think that the global workforce, which of low skills which is 44% of the workforce globally at the moment, will reduce to about 32% of the global workforce by 2030. My own original contribution to this is, and I've not got time to explain it, but I have produced enough papers on it for you to follow if you're interested. But a lot of the predictions about job loss assumed that the amount of work to be done would be stable going into the future. But there is an organic growth in the amount of work to be done of around 10 to 15% per annum. And that means that automation is always chasing the more work to be done. When you actually factor in the fact that a lot of economies like China and Japan in particular are seeing a fall off in the number of people uh, able to do work of work related age, then you can see that there is a good reason why they might be automating like crazy. Having said that, there will be major skills gaps. We're already experiencing major skills shortages in a lot of areas, and they're not all technological jobs. They're not all technical skills jobs by any means. So there's a hell of a lot of work to be done in terms of changing the way that we manage the labour market and the sorts of education and skills trainings that are needed in the future. Let's move on to the next slide. Yeah, the general trend over the next few years is from the kind of work on the left-hand side, typical of low-level skills jobs, to the right-hand side, where the work is more sophisticated, more skilled, often more technical, certainly more cognitive. But as I said, that's not a unilateral move. There'll still be quite a lot of low-skilled work. But the interesting thing to observe here is that uh, the technology doesn't drive skills. The skills drive technology in some ways, because if the skills are not available to utilize the technology, then there will be slower take up of the technology. This is one factor that is very rarely highlighted in all the developments about technology, suggesting that somehow the technology is deterministic. This is not necessarily so, in fact. The other factor here, of course, is many of you will realize that to some extent, as the technologies do develop, they will be eating in to some of the skills listed on the right-hand side. They're not all inviolate skills or characteristics of jobs on the right-hand side. Some of those will be automated. But the other point to make is that distinctive human skills which cannot be automated, of which there are many, are going to become even more valuable in the future. So it's not that all these skills can be automated, and it's not that human skills are going to be devalued. They will actually become more valuable because technologies cannot do those things. If we go on to the next slide, I want to say a very quick word about remote and home working. Then most of our work in that suggests that there are net productivity gains from home and remote working. It makes economic sense, but there are also social factors that can support that, but also inhibit it. And very often, for example, there are people who find it difficult to work at home. They might have the computing power, they might not have the working conditions, and their work might require social interaction. And also, a lot of work cannot be done at home or remotely. I think I saw one figure in one study that said 60% of jobs in the USA cannot be done from the home. So, that's an interesting antidote to this notion that we're all going to do home working quite soon. The other thing is that there's quite a lot of senior executive resistance to home working. They sort of can buy 2 to 3 days of home working by their workers, but on the whole, they don't like much more than that. Certainly, that's what all the surveys are showing at the moment. So I suspect that there will be a move towards a lot of home working as a result of the experience of COVID-19 and what is possible. But I suspect it won't be as big a move as is suggested by a lot of the
Thank
hype
you.
around this.
Thank
The
you, everyone.
next
Bye
slide.
bye.
The next slide. I think what's going to happen, and I don't see this necessarily as a strategic move by organizations, but I think what's going to happen is there's going to be this sort of flexible labor model that develops where there will be core workers who have digital flexibility, who have discretion and high skills that will be treated in one way and will have a good relationship with technology. And then there will be a lot more peripheral workers who are more on a contractual basis that are more surveillanced and controlled by the technology. And there will be a lot of different sources of those subcontracted workers. We're already seeing an awful lot of that kind of work already. And I think that incrementally and in an ad hoc way, a lot of organizations are moving towards this kind of model. And we will see this gradually uh, be populated and develop over the next 8 years. I'll just point that up at the moment. It's a very interesting area of that, and I'm doing a lot of research into that. Very few organizations are strategic in those moves, but you can see the shadows of those moves in the way that they're employing people. Next slide. So very quickly, what you can expect, I think, is low net job loss, but much job disruption and big skill shifts. That there will be bigger impacts when you link automation with these other technologies. Work is going to be seriously reconfigured, but there will be a lot of job growth, and that won't necessarily be as a result of automation and digitalization. There are plenty of other sources of job growth in the future, which sort of ameliorates a little bit this stark view that we're all going to be replaced by technologies and be out of work in the near future. So my very quick lessons, I think, from the presentation on the next slide, the lessons are very quickly, I think you really do now have to listen to the technologies and where they are leading if you want to keep your career on track. I think you need to accept that from now on it's lifelong learning and skills development. I certainly develop my own skills and have lifelong learning on my personal agenda. So I think it seems to work. It keeps you just about ahead of where things are going. Don't be scared that you don't have all these highly sophisticated tech skills. Some people are very good at them. Sometimes you only need certain ones of those technical skills or certain shallow dive into those tech skills. A lot of human skills will be in demand in the future. Typically, what we teach at the LSE, in fact, those ones that I've listed there, critical thinking, analytical, interpersonal, presentational, plus some technical knowledge and skills. And finally, coming in on time just about, finally, Steve, the last slide. If you get interested in this area, I've got a good website, I think, that's very up to date. That's got papers, videos, a monthly newsletter, free papers, etc. If you want to follow up on all this subject, get really interested in it, by all means go online to that. But for the moment, let me hand you back to Dave and on to Angela.
So what we want to do now for the second third of this session is we want to look at this in application. My name is Angela. I work as a Senior Academic Alliance Manager at Celonis. And what we do at Celonis is something called execution management technology. That means namely we look at business processes and process workflows in companies and try to optimize and improve those workflows using, on the one hand side, business insights through data science, and then also more advanced technologies like, for example, automation. And for this second third of the session, what we want to do is we just want to talk about the trends and things that we've discussed and see what those things look like in reality. So the idea is that I'll give you an introduction into two topics. The first technology that we will look at is process mining technology. So we talked about automation beforehand, and we talked about automation being semi-intelligent sometimes, and those different types of automation, integrated automations. There's a lot of effort to integrate automation with other technologies, like, for example, process mining. And process mining is one way to guide automation long-term and to make it less blind, if you want to say so. So we look at process mining as a facilitating technology for automation. And then we'll also look at automation, of course. So I actually want to do a hands-on session with you in Integromat, which is our automation software, where we actually just get a feel of, how easily you can automate things nowadays. So we actually want to do a hands-on live demo, work on a little business case with this and do this. And then towards the very end, we just want to look at the two of them together. So it's quite a packed schedule for 30 minutes. I hope we can manage. But I would suggest we get right into it. Just to start with, because we will work in our Integromat license later, what would be great is if you could register for the Integromat license already now, because for the business case, we will do a live automation in Integromat. So if you want to be part of this, please go to celonis.com/Acal-Integromat. I can just post the link in here as well. So if you could go to this website and just register for a coupon to get the software license. So this is our free of charge academic software license for automation. And by registering, you get an email sent back to you with a coupon, and then after this you need to sign in to Integromat and redeem your coupon to get the corresponding license that you need for this. So please go there now. So all of this is taking place in the background, and we'll be ready once we get to the actual automation. Oh, and please use your academic email address. That would also be great, because otherwise we don't know if you're actually academics and really do have access to this academic software license. All right, so who are we at Celonis? Just very briefly, we at Celonis are currently Germany's only decacorn. So we are a software vendor in the field of process science and data science. We do process mining, automation, and execution management technology. And we were originally founded as a student project by these three guys here. So this is our three founders, Alex, Basti, and Martin. The three of them were students at the Technical University in Munich. And on top of their free time at university, they also volunteered at Academy Consult, which is a student consultancies where students can gain some extra work experience in consulting on top of their studies, and companies get a free of charge consulting service. So the three of them volunteered for Academy Consult, and they met through a project with the Bavarian Broadcasting Service. So the Bavarian Broadcasting Service, that's a little bit like the BBC for Bavaria. And that task was to optimize their IT service desk process, because it took them quite a long time to answer tickets. So they did everything that typical consultants would do. So they looked into the process, they tried to shadow the department, they tried to submit tickets themselves and see what happens with the IT service desk, and so on and so on. And they really couldn't get to the root cause of those problems. So what they did back then is they came across an academic idea called process mining. And process mining essentially was the idea that you could use data coming from companies' IT systems to monitor business processes and to improve them. And this back then was just an academic idea. So this was something that existed on paper, it existed in the form of algorithms, but there wasn't any software, anything like this that was readily usable for enterprises. So what three of them did is they turned this into a software. The Bavarian Broadcasting Service now takes less than a day to answer their tickets. And we've had the idea to turn this into our company and into a business idea. So since then, we've grown quite a lot. So right now we have a current valuation of $11 billion, which makes us currently Germany's most valuable startup. It also makes us one of the fastest growing companies in Europe, with around 100% of growth every year, meaning we double every year. And we have around 2,400 employees right now, and there are over 2,000 enterprise deployments that use our technology right now. So that was just the quick marketing start to get you acquainted with the topic. Now, what do we actually do? What is this technology that I'm talking about? So the first technology that we want to look at is the so-called process mining technology. And what process mining technology does is it essentially looks at business processes. So for us, we look at anything that we can define as a business process. That means we can define it as a collection of related structured activities or tasks that in a specific sequence produce a service or a product. Now you can already see how this relates to automation, because automation does nothing different. Automation also looks at processes that you can automate. One example of this would be, for example, baking cookies. That's a very good example of a process that has clearly defined actions, a clear structure of what needs to be done when. So we can go from preparing the dough to testing our batch, assembling the ingredients, boxing our cookies, doing a last test, and then sending them out with our logistics. So that is one example. And then, as you can imagine, those processes, so this is quite straightforward, but processes can get a lot more complex. So for example, the testing might fail, or you might test the batch and then go back and you would have to start your baking process again for some reason. So there's all sorts of deviations that might occur here. And thinking about this in the automation scope, this already tells us where automation can also go wrong. Because automation, as we heard before, is only semi-intelligent. Automation is usually used to automating workflows as they appear step by step. As soon as your environment gets more complex, as soon as things start to change in your environment, as soon as the process gets more complex, this is usually where automation campaigns start to fail. So adding some extra intelligence to your automation can sometimes go a long way in improving your automation campaign. So this is something that process mining does. Process mining also does a lot more than this. So process mining essentially looks at business processes. So we monitor and investigate business processes with a data science perspective. So we use all of the techniques that you already know from data science, from statistics to data mining to machine learning, and so on, to look at business processes. So what this really means, and now this is a very quick drive through what process mining technology does, is process mining is essentially a data analytics technology that helps to reconstruct, analyze, and improve business processes. And we do this based on so-called log data from transactional IT systems. We'll talk about this a bit more in a second. And therefore, process mining kind of addresses the gap between model-based process analyses and data-centric analysis techniques. So it's kind of in between creating models, having a visual representation, and a data-driven approach. So what process mining does essentially is process mining looks at interactions taking place in the real world. So here we have people, machines, organizations interacting, maybe even bots that you've automated before. And all of those interactions usually leave digital footprints nowadays. So they leave digital footprints in all sorts of IT systems, for example, in ERP systems, CRM systems, on your desktop, through sensors. Whenever you enter a building, whenever you book a flight, whenever you buy something online, all of this leaves digital footprints. And we look at the data that is generated from this, and we use this to discover the process, compare your as-is process to your should-be world, and then long-term improve the process to play this back into the real world. And now I see that this is a very quick drive-through. I would actually like to ask you guys now, when we look at process mining technology, where do you think that automation comes into play here? So where do you think that process mining and automation can be linked when we see that this is what process mining does? Yeah, you can just write into the chat whatever you think. Yeah, someone says recommendations to automate tasks within processes. Very good. That is actually one of the key components, is improving the process and using your process discovery to understand your as-is process. really, really good. So this is also one of the first things that I found out. Of course, it's there. So of course, it comes into play when we look at improving the process long term, but also already for the process discovery, when we use data analytics to understand our as-is process, this is already useful because now we can see what our as-is process looks like, which makes it a lot easier to automate later. So it's like giving some eyes to someone who's blind. So this is what the technology can do. Any other ideas where this can come into play?
Maybe comparing to real theoretical processes and how it deviates from them.
Very good. Yeah. So comparing real to theoretical processes, and this is exactly what conformance checking actually does. So you got this quite right. So we can have our ideal model, our ideal process flow as it should be, and we can compare our ideal process flow to what actually happens. And usually we would want to automate the should be process. So we can first of all take a look at where we deviate in reality, get rid of those deviations, and then start automating, for example. Well done. Yeah. And maybe just to add to this, of course, automation also helps to then add structure, which you play back into your real world. And one thing that we wouldn't think of about very often, but automation also helps to link different systems. So it very often helps to link your ERP system to your Outlook, to your Google Calendar, and so on, to so different applications, different systems. So it also comes into play here when we think about connecting the dots. All right, I get that this is still quite abstract. So I'll try to make this a bit more concrete now, because now we want to take the step from normal automation towards process mining enhanced automation. So let's start with what normal automation is. Also, the reason why we talk about this is that we at Celonis recently acquired an automation software, which we now integrated into our software. The software is called Integromat, and that's the software we want to look at first as a standalone. And what Integromat essentially does, let's see, is Integromat helps to just phase automation. So Integromat is a very simple way that you can automate simple tasks. Like, for example, we have manual processes, like, for example, sorting your emails. And automation can help here because usually you have a lot of manual steps involved in some very repetitive tasks. Like, for example, you receive an email and you want to sort your email into different folders depending on the topic. And then usually what happens is when you do this manually, you receive an email, you read it, you decide for the correct folder it should go into, you create that folder, and then you save it to that folder. And then, of course, when we do this manually, there's a lot of potential for human errors, like, for example, forgetting to read the email, making the wrong decision when it comes to changing any factors or anything like this, forgetting to save and create a new folder, and so on and so on. So simple automation just deals with automating things like this, and letting these things take place automatically. All right, and I can already see there's lots of discussions going on in the chat, so hopefully we'll have enough time towards the end to look into this. Now, the problem with automation very often, however, is that it is a lot more complex than we think. So the real world process usually is a lot more complex. Usually there's a lot more different systems involved, a lot more complexity. So that means that we have problems when we automate. So now, as a situation, usually we have a lack of IT capacity to support automation projects. We have siloed data. We talked about this beforehand. And usually only a fraction of the potential of the automation and of the applications is being leveraged. There's actually a statistic that was given out by EY, I think 2 years ago, saying that around 70% of automation campaigns fail in business nowadays. All right, let's go to this one. So we want to start by looking at simple automation, and we want to look at this together in the Integromat software, and then we want to see how we can enhance this. So what we'll look at in the Integromat software now is we'll just try to automate a simple workflow. And there's always a very certain logic behind this. So usually you choose where you start. So you decide for a trigger that can start your automation. So a trigger might be, for example, an email coming in or something like this. It might also be, I don't know, when you have a Google Sheet and there's a row added to your Google Sheet or something like this. Something like this could be a trigger that starts our whole process flow. And then starting from this, we can add different connectors. So we can say that when this happens, let's store the data somewhere. And we can even add some logic to this. So we can even say, we might add something like a router saying, if this happens, let's do that. If something else happens, let's do something different. So depending on this here, this is just about sorting your emails. Your email might either go somewhere into the cloud or it might be archived in a different cloud. So just like this, you can start with a trigger, you can add some logic, and you can connect all sorts of applications. And this is also what Integromat does. So Integromat essentially offers your platform to integrate all of those different applications. Okay, let's look at this with our business case. And I realize we're quite tense in time, so we'll try to do this in 10 minutes. We have a pizza business that we want to look at. And okay, let's start here. By the way, can I get a quick, just like a quick reaction from you guys? Did you guys all have access to your academic software license? Did you receive an email? Yeah, I see a few thumbs up. Maybe you can just quickly put your thumbs up if you have access. Yeah. Otherwise, if you don't have access, I can put the link in here again. So after you received your access, you can go into Integromat, redeem your voucher that you received via email, and then you should be ready to go. And we'll look at problem number 2 for reasons of time. So we're looking at a pizza business. We have the Pizzeria Mamma Mia, which is owned by Giovanni. And the Pizzeria Mamma Mia, they have 2 KPIs that they specifically look at. One of them is customer satisfaction, and the other one is revenues. And the problem that they have is they receive a large amount of delivery orders, and it's extremely difficult for them to have an overview of the whole chaos of orders that they have. And what happens is the pizza is extremely good, but for some reason the customer satisfaction level is quite low, because customers sometimes don't receive their orders a bit late, or sometimes we have problems like we're out of a specific ingredient and we need to inform the customer that we can't produce the pizza that they want. So this is also the business problem that we want to face here. So we want to look at the Pizzeria Mamma Mia, and they have 2 problems. So first of all, we have a lot of orders coming in via email, and it's a mess to manage. So we want to start an automation that helps us to respond to every email order that they receive, and just gives them a confirmation email saying when their pizza will arrive. And then the second problem we have is whenever people order Pizza Hawaii, we're out of pineapple, so we can't take any more orders for pineapple. So we need to inform people that whenever they order a Pizza Hawaii, we're out of pineapple. And now what we want to do is we want to take a look at this in Integromat and see if together as a team, we can automate this process. Okay, so let me just jump into my other software license. Okay, great. So for the sake of simplicity, I created this Google Forms where pizza orders come in. So we have this pizza order Google Forms here, where essentially everyone can say what kind of pizza they want. So we have pizza orders like, for example, pizza margherita, pizza fungi, pizza salami, pizza Hawaii. You can say your name, leave your email address, and tell them where they should deliver to. And this is great. I'm also going to post the link for this into the chat room, because we will need this in a second. So this is our Google Forms link. And what we have behind this is we also have a responses sheet. I deleted this, so I deleted all of the previous responses for reasons of data protection. But essentially what we have in the background is we have a Google Sheet where whenever responses come in, we collect the information about what they've ordered. And now what we want to do is we want to use this to orchestrate our orders. So what we can do now is we can now go into Integromat. By the way, if you haven't redeemed your voucher yet, if you go into Integromat, I think if you go to scenarios, I think there should be something up here. either under scenarios or under dashboards, which says redeem your voucher. It doesn't say it on my license because I already have the premium license and you guys still need to get it. But this is where you can essentially redeem your voucher to get going and get started. Maybe we can just have a quick feedback again. Did that work for you guys? Did you get access to Integromat? Maybe we can just have the thumbs up again. Yeah, and Sarah just commented where she redeemed it from. So if you go to, okay, if you go to my lab, I can also go into my own account here. And then the top right, you can redeem your voucher.
It's a subscription, so your own dashboard, then user subscription.
Yeah.
Just there.
Thank you. Yes. So I think,
and then it's right on the right, top right.
Yes, perfect. Thank you. Thank you so much, Sarah. Perfect. So if you go to dashboards, then subscription, and then here you can redeem your coupon, because then you're able to work with this. Thank you, Sarah, because yeah, it's been a long time since I did this.
No problem.
All right. Is that clear and makes sense for the rest? I hope so, because I really don't want to rush you too much, but let's see. Okay. So let's all create a new scenario together. So once you've redeemed your voucher, we click on Create New Scenario. And this essentially means we can now just start from scratch. So I would invite you, while we speak, that you just do this in parallel together with me. Oh, and someone says they can't find dashboards. Yes, thanks, Sarah, for managing all of those requests. So what we can do in here is essentially we can add triggers and connections, and we can add some process logic. So let's start. So what we can see is when we click on this little plus here, that suddenly we have this bar opening here, giving us a list of all of the different applications that we can link with Integromat. So here we can see it's a lot of really, really different things that we can link. We're specifically looking for Google Sheets. So I just typed in Google, and when I did this, I can get to Google Sheets here. And I clicked on Google Sheets, and what we want to do is we want to set this as a trigger. So you can either define whether you want to set a trigger or whether you want to set an action. Trigger means whenever something comes in, we react. Action means this is the reaction. We want to use this as our trigger to trigger our automation. So what we can do is we can just say, okay, let's watch the rows. I think that's what we're interested in. So we're interested whenever a new order comes in. All right. Now what I'm going to do is I'm going to share this spreadsheet here with you guys, so you also have access to the spreadsheet. Oh, I'm wondering if I can share the spreadsheet with you. I didn't think about that earlier. Let's see if I can copy the link. Nah. Okay, this is not looking very good. Let's see if it still works. So I can try to give you access. And we can just do it in here. So we have this responses, pizza orders responses sheet that we want to connect. So what we can do is we just say, okay, what do we want to connect? Oh, right, and I'm in the wrong license. I'm so sorry, guys. Need to go out of here again. Sorry, just give me a second. I need to go in here. Okay, let's just do what we did before. We want to create our scenario and select the sheet and watch our rows. Okay, now what I can do in here is I can first of all select that I want my own Google Sheets connection. So this says that for me, I want to connect my own Google Sheets account. So this is my Google account that I'm connecting. Then from my Google account, I can select the spreadsheet that I want to watch. So you can see I have quite a lot of different spreadsheets. Let's see if we find the pizza one. There we have it. It's pizza order responses. And maybe it makes sense for you guys to just watch and sit back for now, because I'm a bit afraid that you might not be able to do it on your laptop unless you want to create your own Google Forms and just add your own connections. So that's also a possibility. So in here, we just say we select our pizza orders, and then we want to select the sheet where the information is, which is this one. And it just asks, where does this information sit? And then the maximum number of results. Let's just up this a little. Maybe let's say we can have up to 100 results. And this is our trigger. And then it asks us, where do you want to start? Do I want to start in a specific row, or do I want to look at all of them? I just say I want to look at everything that comes in. So this is our trigger. We can now connect this and add another module. So what we want to do is probably we want to have something, something like a router. Oops. No, not here. Sorry about this. Typical effect when you want to show something. Here we go. We want to set our router and connect the two of them. So this essentially means we now have a logic in here. So as we said, we want to send confirmation emails to everyone who orders a pizza and send a different email to those people that ordered a pizza Hawaii. So we use the router for this. So now we can add two different scenarios. And we can say, okay, we want to send emails. So let's see if I can find my Gmail address. And this is great because now I can just say, okay, here's my email and I want to send an email. This sounds great. And then I can just select again, okay, this is my Gmail address. If you do this by yourself, you would have to connect your own Gmail account to the software license or whatever other email provider you guys are using. So I just say I want to send an email from my account. And I want to send this to the people that have ordered. So here we can refer to our Google Sheets again. And we know that the information says, what is your email address? This is what I want to send to. Okay, this sounds great. And then we say the subject is thanks for your order. And this is great. And then we just say, thanks. Your pizza is on its way, will be there in 10 minutes. Okay, this is great. And this looks all good. No attachments needed. Okay, this is the email we want to send. And then we can specify in here when we want to send this email. So we can click on this little tool button in here, on the connection in here on the tool button. And then we can say, okay, what is this? When does this happen? So this happens actually for every order except Hawaii. And we want to give this a condition. So we want to say when the pizza they want, what pizza do you want, does not equal Hawaii. Okay, so this is every other pizza. Now we have another scenario where we want to send an email whenever this is Pizza Hawaii. So again, we want to send an email and we say it's sent email. It's the same thing again, only this time. So I select my connection again. I send it to the people that have indicated the email address. Only this time we're out of pineapple. So we say, sorry, no more Pizza Hawaii. And what we can say in here is, sorry, we are out of pineapple. Could you tell us what you would like instead? Okay, this looks good. And then we just specify that this happens for all of the other cases. So we say this is Pizza Hawaii orders. And we say this is for all of the pizzas that are equal to Hawaii. Okay, now this looks quite promising. Now, I would invite you guys to test this now together with me. So what I would ask you to do is we want to go to this Google Forms. And remember, I sent you this link. I can send it to you again. By the way, I feel like this is a huge Google commercial that we're doing in here. So here's the link. If you guys would just like to go there and order your pizza And then we can run the scenarios together and see if you receive either a confirmation email or a message saying, sorry, we're out of pineapple. Okay. So maybe you can just give me a quick thumbs up whenever you've placed your order. And sorry, I think it was impossible for you to do this by yourself during the session, but you're very welcome and you're invited to do this after the session by yourself if you want to repeat this and build your own scenarios. The software license that we gave to you is also one you can use for all sorts of study-related purposes. So whenever you want to write, I don't know, a thesis or something like this about automation, or you have a student project to work on, you're very welcome to use the software license. So you have a half-year free access to the Integromat business license as a student. Someone asked if they can still order Hawaii without pineapple. So maybe this is what you need to write back to whenever you receive this email. But what's the purpose of Hawaii without pineapple? I think it's a key characteristic of Pizza Hawaii. Okay, let's see. Have you already collected some responses? Maybe we can refresh our Google Sheets. No? Ah, yes, we have here. Okay. So then let's see if we can run the scenario and if you guys receive an email. So now what it does is it goes into your Google Sheets and it starts watching the rows. So it starts to look and see if there's anything happening in those rows. And it does this for quite some time. I think it might have some problems because I deleted some names earlier on, so that might be problematic. Okay, but I think you guys might have received something already. Did you receive something? Did you guys already receive a message? Yes, no? No? Okay. Oh, okay. So then let's see if we can optimize this. Maybe we can put your orders up here just by deleting the other rows. Oops. Okay, let's try this again. I think this might be, whoops. Let's run this again. Okay, here we go. I think there's some emails coming in now. So I think the problem was that we had empty rows, which made the scenario stop. All right, and I think people did receive their emails. So this is good. Yes, perfect. Brilliant. Brilliant. So we managed. Very well done. Now, I hope it made you proud to actually feel that we automated our first scenario completely spontaneously and not as a planned trick. You could also see that there are a couple of things that can easily go wrong with those automations. So you could see, for example, whenever I've had empty rows, my automation scenario would stop, the automation would fail. So you could see that those scenarios are great and they're a very simple way to quickly automate processes, but they can also easily fail. So what I would like to do in the next 3 minutes, and then I promise we're over with this part, is I would just like to give you an outlook into how process mining that we talked about earlier can help to make automations like this more intelligent. Okay, so let me see if I can share my other screen. Okay, here we go. Okay. Just see if it loads. Okay. Now, the example that I brought to you as a last real-life example for you to see how this works in reality is a procurement example. So we are looking at a purchase-to-pay process within a business. So this means this time we're not dealing with pizza orders, but actually we're the one who's ordering. We're a company buying something off from another company. And we can watch this purchase-to-pay scenario with the help of process mining and facilitate our automation through this. So what we can see with our business analytics that we have is, first of all, we have 27,000 purchase order items, so it's quite a high volume of transactions. And we can also see by looking at the different dashboards that we have here that we have quite a high manual touch rate. So the manual touch rate means this is the percent of cases where someone has to manually intervene to make this purchase order flow through the process. So this on the one hand side indicates that our employees are super productive, but it also means we have a lot of manual work. And now we can use this, and this is compared against an industry benchmark of usually just 38%. So there's a lot of savings potential when you think about, the employee power that we have behind this, just employees doing repetitive tasks. When you think about automating this, there's so much money we can save by using those employees for different tasks instead. So we can use process mining now to understand this process better and understand why the manual touch rate, so the amount of interactions you have with real people, is so high. So we can move over down here. We have different sheets, and we can just move over to our discover and quantify sheet. And we can see that with the help of process mining, we can now recreate this purchasing process. So we can see that here our purchasing process usually consists of different activities, like, for example, creating a purchase requisition item. So this means someone goes to the purchasing department and says, could we please buy this? Creating a purchase order, sending this one out, price changes, sometimes as a deviation, receiving our goods, scanning the invoice, and booking the invoice. So you go from purchasing to receiving your goods to paying your goods. Now we can also see that in reality, this process is a lot more complex. So the streamlined process would look just like this, but then in reality, we have deviations. So we have price changes, which make this process more complex. We have sometimes order confirmations. We have done order confirmations, and so on and so on. So you can see that this process gets more and more complex and more tangled up the more variance we add. And you can also see that we have this color code here telling us how automated those different process steps are. And you can see the green is great. Green is very well automated. Red is not so great. So this here is only 16% automation rate. So we can also use this to do an automation scan. So we have this scatter plot up here, looking at the manual rate, so the rate of manual work, and looking at the frequency of the activities. And then we can see that what we can identify right away is that this change price is right here in the upper right corner. So this is really the intersection of tasks that happen super often and tasks that require a lot of manual rework. So I'm not sure if you guys are purchasing experts, but change price means essentially that in your IT system, you usually have a baseline price that you've agreed on with your vendor. So whenever you buy something, you say, this is the price that we buy it at. You get the invoice, you pay for it, that's it. Whenever the price varies and is different from this baseline price, this means that someone has to manually go into the system, check up the price, see if the new price is okay, and so on and so on. So this is where the manual work comes from. And we can zoom into this a little bit more. So we can zoom into those manual price changes. For example, by using additional information, for example, from desktop interactions, telling us how complex this price change is normally. So normally what happens when I try to automate something is I try to understand the process as well as possible. So I can, for example, see that here we have the simple change price activity, which happens in 152,000 cases. In 128,000 cases, this involves someone browsing through Outlook, looking at your PDF with your price, and then changing this in your IT system and entering the new value. So there's a lot of actual manual steps involved behind this. which usually when you try to automate, you don't get. You don't get the manual steps behind this. So you can use this to add extra transparency to your automation. And what we can see now is we can first of all see how complex this actually is. So this helps us to guide a better automation. And we can also focus a little bit more on the price changes in general. So what we can also see is we can see that when we take a look at this chart over here, most of the time, most of the price changes come from small changes. So where the price differs less than 5% from the baseline price. So what we can do now is we can use this to set actions and to say that, for example, for all of the small ones, let's automate the process. All of the big price changes, let's just notify someone and they can do it. So we can take action directly here out of the system. And we can now also do this with Integromat, but this here is just a different way to show this. So we can actually use as a trigger, we can use our Celonis system. So we can use process mining to set a trigger, which is a lot more sensitive than just setting a static trigger, like whenever something comes in, let's do this. Whereas this one here could even sense predictions. Could even say that with machine learning, I can predict whenever a price change is about to happen. And even before it happens, I can trigger the automation. So I use this trigger here to say, based on my data, I think it's likely that here we'll have some price negotiations going on. And then I can see if the price difference is less or more than 5%. And if it's less than 5%, I can just program a bot saying this bot will send a message to the procurement lead and change the actual price in our systems. And if it's more than 5%, let's just prompt someone and tell them that they need to update the price in SAP. So let's just get manual approval, and that person will manually be able to say, yes, we still want to change it. So just like this, we can make our automation a lot more sensitive, and we can use other technologies like process mining, for example, to be like a guide dog for otherwise more or less blind automation.
A lot of the attendees that we have here today are very interested in careers in process mining and data science. So as they plan their careers, what is the best piece of advice that you could offer them?
Yeah, I think for me, the central thing is just to be open-minded and be aware of what technologies are out there. I think one of the key problems with our university system at the moment is that we tend to be taught quite a lot about things that were up to date 10 or 20 years ago. And there's so much change and so much disruption happening in technology nowadays that it's hard to keep up with those things. So this is, for us, this is a motivation why we as a company also take a share in education to let students know about the technologies that exist out there. We definitely also have our own incentives behind this, but it's also great for students to be up to date, to know what's going on. So definitely be open-minded for this. And what we, for example, do at Celonis is we offer different certification programs. So one thing we run together with LSE quite frequently is we run a masterclass in data-driven management. The next one will be run over the summer. So you can take part in those things. So do everything you can do to upskill and do everything you can do to be aware of new technologies and open up your skill set.
For my part, I think people ought to think about a couple of things that haven't come up. I think people should be doing what they like to do in terms of work. And if that's allied with what they're very good at, then they have a very nice blend. There's still a lot of room for doing what you like to do, and you tend to do those things with much more passion and more commitment and better on the whole. So, if you just look at the technical area, there are people who just love technology. I'm not one of them. I love what it can do, but I don't love working with the technology as such. But working with data, I love. Data analytics might be the area that some people really want to focus on, because that's the part of their brain that they like dealing with. Other people might actually not like the technology at all, but there are plenty of jobs and kinds of work, even in high-tech industries, that are available that don't require huge amounts of technical skill. And there are different ways of relating to the technology. You haven't got to be all hands-on physical developers. There are so many different kinds of work requiring different kinds of technology knowledge, technical knowledge. So I'm not proficient at all in technology, and I never wanted to be, but I am a professor professor of technology, work and globalization. And for my sins, I advise a lot of companies on these areas. So uh, that's what I'm hopefully like doing, but also what I'm become good at. So it's a deeper piece of thinking than being instrumental about work, I think.
Do you think that the asymmetric conditions between countries will directly impact the process of digitalization? And what will happen to those markets that are unable to include critical thinking and analytical skills that Leslie mentions?
Technology is never neutral in its impact. It's always being used politically by someone, i.e., in their interests, within organizations, within countries, against countries. So, yes, there will be asymmetric development and use of these technologies. That's why countries are trying to get ahead in the use of so-called AI. Why China has wants to be the world's leader in that by 2030, because they know that the result will be asymmetric. So that was the first part of the question. The second part was, what happens if you're using technology that doesn't require human skills? Was that the question? I just don't really people seem to think that there is such a thing as full automation. That's very rarely the case in business. You're always surrounded by human skills. Most of the suppliers these days, vendors of these technologies, talk about hybrid work, complementing humans with technology and software. And that's the way forward. And it might be that the balance is more in the direction of software and the technology, but in some parts of work. But there's always going to be room for human skill, because these technologies are it's so imperfect, and even when they work well, they have limitations.
So if we have no further questions, I would like to draw this session to a close by thanking our speakers for being so generous with their time, and to all of you that have attended this event as well.